Warm welcome to one and all. Myself, P. Yamachandra Prakash. Currently doing our B.Tech final year in Well-Tech Dr. Dr. Technical University. We have done our final year project on computational studies and characteristics of micropropeller. We have done in-house projects. Our batchmates are Mohammed Fawaz and Sheikhul Suleiman. Our internal guide was Karthikeyan sir. Thank you.
I am going to explain about our project. Our project is computational studies on characteristics of micropropeller. This is the introduction of our project. This is a small scale propeller have been widely used in radio controlled RC aircraft. And the objective of the project is to find the performance of propeller whose diameter is 0.7 meters. The propeller performance is critical of the success of unmanned aerial vehicles. And we have used ANSYS system and XFLRI. And these are the literature survey. And the computation works on the propeller is the 3D unstructured grid. We have used more than 3,03,000 cells, and the solid disks are pressure based incompressible flow and 3D steady flow. The velocity we have taken are 8, 10, 12. The boundary condition is inlet is velocity inlet and velocity is pressure outlet and propeller is valve. We are giving the rotation frame of reference to the rotation fluid respect to the blade axis, as it is considered as a less time consuming process. The dynamic mesh where blade will be rotating and consumes lot of time. The unstructured grid contains outer domain diameter is 1000 mm and inner domain is 90 mm. And this is the ANSYS 3D geometry with rotation region, outlet, fluid entrance and 3D geometry. This is our propeller design consideration. We have taken NACA 66021 and Propeller 193. This is the propeller, and this is the inner domain. The propeller is present inside, and this is the outer domain. The propeller is present inside. These are the boundary conditions which you have velocity inlet, pressure outlet and valve. XFLR5, the green color indicates NACA 66021 and red color indicates Propeller 193 airfoil. The CFD analysis is done through 6000 rpm to 12000 rpm at 4 meter per second to 16 meter per second. This is the 2 meter per second at 6000 rpm. The graphs are obtained. This is the contrast of pressure. This is 7000 rpm, 8000 rpm, 9000, 10,000 and so forth. The graphs we obtained are coefficient of power versus advance ratio, coefficient of thrust versus advance ratio, efficiency versus advance ratio, CD and CL versus alpha. This is the coefficient of power versus advance ratio, and this is the thrust versus advance ratio, and this is the efficiency graph. We are getting good efficiency at 8000 and 7000 rpm, and this is the CL versus alpha and the graph. And the conclusion is the maximum chord of 40% of blade height, and the maximum chord is given more thrust. So the good performance in row Reynolds number operating system, extensively used in CFD tools as empirical equations. And these are the reference